So this problem is about finding distinct elements. So we have an array like of numbers and we allow to make a single operation on any of these numbers. And what we can do, we can do plus or minus up to the k. So we can add or remove any number in a range of minus k to the k. And after this operation, we want to find the maximum of the resulting distinct numbers. So imagine we have this kind of numbers, like 5 ones. And imagine we have k equals like 2. How can we apply this operation to make the maximum distinct numbers? So we can think about this problem like some optimization problem. Imagine we achieved some result, like have k minus 2, and then we do it to the first number, and it is minus 1. And how do we allow to make another minus 2 operation? The answer is no, because the numbers are all equal. So we do next operation like minus 1, and this becomes 0, and so on. We like plus or minus 0, it just is 1. Then again plus 1, and this becomes 2, and plus 2, this becomes 3. So the answer is 5 distinct unique numbers we have after applying. So the strategy is the following: we have k, and we have this range from minus k to the k. Like in our case, it's minus 2, minus 1, 0, 1, and 2. So we have 5 distinct operations. And if our numbers are duplicated, like 5 ones, all of them can be included to the result. And if we have, for example, 6 ones more than this range, that means we disallowed one number and we take other 5. So it is close to the solution, but we're still not there yet. Let's think about how can we approach this for not equal numbers. Like imagine we have 1, 1, 1 and 2, and then 5, 5, like this, for example. And k is, maybe it's 2. So what, in this case, what can we do? First of all, we should sort it. It's pretty cheap on nlog, and then we have more simple way to use this array as a sorted version. Next, what we can do, we can find the duplicates. The uniques are already can be taken. It's no problem. The problem is duplicates. We can't take them. So how can we take the duplicates? As we mentioned earlier, we can take as much as 2k plus 1 duplicate numbers. It's the range of operations. So we can take all of this, and we can take all of this. But what if we have some tricky case where we have, like, for example, 4 ones and 3 twos, and the k is 2. The simple strategy to take just 2k doesn't work here because they actually intersect with each other. If we do in this -1, this be 0, 1 and 2, and this 2 is intersected with the next. So we have to consider this, and what can we also do? We should reimagine how we solving this problem, and it's not just taking this kind of duplicates. Let's take it one number by one, and as our array is sorted, we can just track how many numbers we already used in a single variable. If it doesn't sort it, we also can do this, but it will be more tricky version. So we go from the left to the right, from the minimum to the maximum of these numbers, and we check. So imagine we have first number k. K is 2 and the number is 1. And we want to check, are we allowed to take it or not? So that means we know about the previous parts, like some numbers are already used, and this previous part is also sorted, kind of sorted, because we going from the lowest to the highest, and we can just store one maximum used value. And for the current number, we're checking if it is in a range of, like, can it be used as max plus 1, for example. This is max plus 1. We can put it, or if it's like far from this max, we just take it, and there is no restrictions. But we want to take as small as possible number, because we want to make sure other numbers that would follow this all will be taken. So we take like for this example 1, we take it like 1 minus 2 minus k, because this is a minimum of the range, and we should place it in or either or this position, like max plus 1, or if it is stayed far from this max plus 1, we just take it like x, or number minus k. This is a minimum. So we choose this between these two, and we update this maximum value, so no other values would intersect this. So the max is equal this max plus 1 or x minus k, and we choose between them the maximum. So this is algorithm, and it is greedy. It's called greedy because we just greedily take number. And let's look at the solution. My solution basically the same. It checks if it is in the range, and then I updated the maximum value. One little mistake I made is I stopped when the maximum is out of range, but I shouldn't made this, because there are some numbers that are like big jumps, and We just have to update our maximum to it. Continue. So that's it, and now you can watch how I solved it, and in 20 minutes